Okay, class, so today we're going to learn the algorithm of solving equations using addition and subtraction. We're also going to go ahead and take a look at the model and why this method works. Now, the thing about algebra and balancing equations is that we have to remember that both sides of the equation has to be equal. So x plus 3 is going to be equal to 8. That means whatever value x is, x plus 3 has to equal 8. Okay, so what we're going to do is we're going to do an inverse operation here. So since it's asking me to add 3, I'm just going to go ahead and instead take away 3 and take away 3. Now, the reason why I'm taking away this 3 is because I want the x to be all by itself. In order to get the x to be all by itself, everything else has to equal to 0. Now, a positive 3 and a negative 3 will in fact give me that 0 that I need in order to make sure that x is all here by itself. Now, once again, this is algebra. Things has to be balanced. So because I minus 3 on this side, I have to minus 3 on this side of the equation. So I'm going to go ahead and take away 3 from 8. So 8 minus 3 is going to be equal to 5. Now, x has to be 5. Now, let's just go ahead and check and see if this is true. So I'm going to substitute x for 5. So x is up here. 5 plus 3 is going to be equal to 8. 5 plus 3 is in fact 8. So 8 is equal to 8. Now our equation is balanced. We'll go ahead and see this from a model as well. So if we go over here to our model, we have x plus 3, 1, 2, 3 is equal to 1, 2, 3, 4, 5, 6, 7, 8. Okay, now what I'm going to do is I'm going to go ahead and take away 1's from the side that the x is. Okay, so I'm going to go ahead and do that right now. As you can see, I'm going to take this one away. So that means I got to take this one away. If I go ahead and take this one away, I have to go and take away this one. Then I'm going to go ahead and take this last one away. So then on this side of the equation, I'm going to go ahead and take this one away. As you can see, x is now equal to 5 because I took 3 away from one side of the equation and 3 away from the other side. That's why this method works. Now let's go ahead and do a couple of practice problems. Let's say we have x plus 14 is going to be equal to 21. Now, I have addition. That means I have to perform my inverse operation. My inverse operation is going to be minus 14. So I'm going to take away 14 from both sides of the equation. It's very important that I take it away from both sides. Now, positive 14 and negative 14 is going to give me a 0. So x is going to be equal to, now let's go ahead and borrow. I can't take 4 away from 1, so I'm going to go ahead and borrow. So it's going to be 11, 10, 9, 8, 7. So x is going to be equal to 7. X is equal to 7. Let's go ahead and try another example. Grab my blue. Okay. So we have x plus 11 equals 47. Now, once again, I have addition. I'm going to perform the additive inverse. So I'm going to subtract by 11 and subtract by 11. Now, positive 11 and negative 11 is going to give me 0, which is exactly what I want. So x is all by itself. Now I'm going to go ahead and take 11 away from 47. So 7 minus 1 is 6. And then 4 minus 1 is going to give us 3. So in this case, x is going to be equal to 36. And once again, I could always plug in for x and then see if it's correct. 36 plus 11 is 47. That's absolutely true. Now, let's go ahead and take a look at an example that has a negative answer all by itself. I'm going to show you that we're still doing the same exact thing. Okay, so x plus 3 is equal to negative 7. I need to get the x all by itself, so I'm going to go ahead and take this 3 away and take this 3 away. Okay, this creates a 0 pair. That means they cancel out to equal 0. So now I just have x on this side, which is exactly what I want. Now, if we go ahead and try to remember our integer rules, we have negative 7, and we're going to take away 3. Now, once we leave, change, and change, we actually have negative 7 plus negative 3. Negative 7 plus negative 3 is going to give us negative 10. If we're adding two negatives, it's just going to be a smaller negative. So x has to be equal to negative 10 in this situation. And this makes sense. So let's go ahead and plug it in to see if this makes sense. So we have negative 10 plus 3 is equal to negative 7. Negative 10 plus 3, signs are different, so of course I have to subtract. But since the absolute value of 10 is higher than the absolute value of 3, I have to keep that negative sign. So negative 7 is equal to negative 7. Okay, and that's it for adding equations with the additive inverse. Now, we're going to go ahead and go to subtraction. Same thing. Now we have a subtraction sign. We have to do it in reverse. So I'm going to go ahead and add 2 and then add 2. I have x all by itself, so 6 plus 2 is going to be equal to 8. Now, as you can see, I just performed the opposite of what I did from the first couple of problems. This told me to subtract 2, so I have to do the opposite, which is to add 2. Now, let's go ahead at the model on the side over here to see why this works. Now, I have x minus 2 is equal to positive 6. I'm going to go ahead and add 1 over here. I'm going to go ahead and add another one over here. Now, I added 2 on one side. Now, I need to add 2 on the other side. Oops, sorry about that. Here we go. Now, I'm going to go ahead and add 2 on this other side. So, here's 1, and here's 2. So, my final answer is going to be x equals 8. As you can see, it's the same answer we got over here. This is why this method works. So let's go ahead and try a couple more problems with subtraction. Let's say we have, let's try x minus 12 is going to be equal to 5. I see subtraction, I have to do the opposite. Add 12, add 12. Actually, let me go ahead and make this purple so we could see what we're doing. So add 12 and then add 12. This cancels out because negative 12 and positive 12 just equals 0. We have the x by itself, which is our goal. Now 12 plus 5 is going to be equal to 17. So what this is saying is 17 minus 12 is equal to 5, which is absolutely true. Let's go ahead and try another example. X minus 3 is equal to negative 4. Okay? Now, what I'm going to do here in this situation is I'm going to add 3 and then I'm going to add 3. This cancels out to get x by itself. Negative 4 plus 3. Let's see. Negative 4 plus 3. I see that the signs are different, so I know I have to subtract. So 4 minus 3 is 1. It's going to be a negative 1 because the absolute value of 4 is bigger than the absolute value of 3. So my answer is going to be negative 1. Okay? Let's try this last problem. This one can seem a little tricky. Now, the thing about this is that we have a negative on the outside, and then the sign is positive. Okay, so this can be a little bit confusing. You may think we have to do the opposite of this addition, which is subtraction. But if we do that, we're actually just going to have negative 6 plus x on this side, and then we're going to still add subtract 3 over here to get negative 10. So that's not what we want. So instead, in order to get this negative 3 away, we actually have to add 3, and then we're going to add 3 over here. So x is going to be equal to negative 4 in this situation. X is equal to negative 4. Okay? And that's it. Add in and subtraction with solving equations.